Welcome to today's presentation on switched computer networks. So a switched computer network is a type of network that uses specialized devices called switches to forward data packets between nodes, right? So switches are intelligent devices that can examine the destination address of a packet and forward it to correct destination. So we are going to explain circuit switching and packet. Right. So on circuit switching, we are saying that this is a technique used in switched computer networks where a dedicated communication path or circuit is established between two nodes before data transfer begins. Right. So in circuit switching, a dedicated circuit is established between the sender and the receiver before data transfer begins. So the circuit is reserved exclusively for the use of the two nodes, and no other nodes can use this circuit until the connection is terminated, right? So when the two hosts initiate a connection, the network determines a path through the intermediate switches and establishes a circuit that is maintained for the duration of the connection. When the host disconnects, the network releases the circuit, right? So we have steps that are followed during circuit switching. The first one is circuit establishment. The sender sends a request to the receiver to establish a connection. The receiver accepts the request and a dedicated circuit is established between the two nodes. So to establish an end-to-end connection before the any transfer of data, some segments of the circuit may be a dedicated link, while some other segments may be shared. Another step is data transfer. And here we are saying that once the circuit is established, data transfer can begin. The sender sends data packets to the receiver over the dedicated circuit. So this transfer data from the source to the destination. The data may be analog or digital depending on the nature of the network. So the connection is generally full duplex. Then there is a circuit disconnect. So when the data transfer is complete, the circuit is disconnected, right? And the dedicated path is released. So we are saying that to terminate connection at the end of a data transfer, signals must be propagated to deallocate the dedicated resources, right? So an example that I want to give, suppose we have two nodes, A and B, that want to communicate with each other using circuit switching. Node A sends a request to node B to establish a connection, which is the first step, circuit establishment, right? So node B accepts the request and a dedicated circuit is established between the two nodes. Node A then sends data, right, packets to node B over the dedicated circuit, which is data transfer. So when the data transfer is complete, the circuit is disconnected, which is circuit disconnect, the last step, right? We move on to packet switching. And the packet switching is a technique used in switched computer networks where data is broken into small packets and each packet is transmitted independently over the network, right? So in packet switching, data is broken into small packets and each packet is given a header that contains the destination address. So each packet is then transmitted independently over the network, and the packets may take different routes to reach the destination, right? Unlike circuit switching where communication is continuous along a dedicated circuit, in packet switching communication is discrete in the form of packets. So each packet is of a limited size and can hold up to a certain number of octets of user data. So larger messages are broken into smaller chunks so that they can be fitted into packets. In addition to user data, each packet carries additional information in the form of a header. I explained this to enable the network to route it to the final destination. So we have of packets, right? These are two variations of packet switching. We have virtual circuit and datagram. So on virtual circuit, we are saying that a logical connection is established between the sender and the receiver before data transfer begins. Each packet is given a virtual circuit identifier, and the packets are transmitted over the network using this identifier, right? So the result is a circuit somewhat similar to those in circuit switching, except that it uses packets as its basic unit of connection. Then we'll move on to datagram method. In datagram packet switching, there is no logical connection. So this means that this is connectionless and does not rely on a pre-established route. Instead of, each packet is treated independently, right? So each packet is transmitted independently over the network, and the packets may take different routes to reach the destination. So it is possible for different packets to travel along different routes in the network to reach the same final destination. So as a result, packets may arrive out of order or even never arrive due to node failure. So it is up to the network user to deal with lost packets and to rearrange packets to their original order. Because of the absence of a pre-established circuit, each packet must carry enough information in its head to enable the nodes to route it correctly, right? So if you have questions, feel free to write in the comment section, and I'll answer in the comment section. And also feel free to comment in the comment section. Thank you for your time.